what are those guys doing? Like, why are they using ZFS? Why did they choose ZFS? What are they actually selling? So that's what these talks are going to be about. They're going to be pretty quick. I'm going to try to hold you to the 10-minute line, and we have, I think, everyone's slides on this laptop, so you can just use this laptop, except for the last one. A couple of quick announcements. The swag that's out there is all free for the taking. Please take some today. And I'm especially proud of the little Z stickers. If you didn't figure out what they're for putting over your Z key. So now it's an OpenZFS key. And the t-shirts that are over there, there's actually two kinds of t-shirts. There's the one that you got with your registration, and then there's actually a different t-shirt from the HA storage virtual. So with that, I will introduce our next speaker from Korea.
I will just say I have a slide, but I can send it out by email or whatever. Do we have a conference?
We'll send out an email
Wiki or something? For sure, yeah. Just additional background info. But I want to say welcome everybody. I'm glad to be here and that we have a great crowd here today. And this is a real great trust of ZFS in the world. So thanks for coming in. At Corade, we're a small, we keep calling ourselves startups, but we've been around for about 10 years, delivering product. And the founders of Corade invented the ATA over Ethernet protocol as a simple way to have block device blocks sent over Ethernet layer 2. And it's a very fine way to generate very scalable high bandwidth systems, and in a cost-effective manner because it's simple. And simple is good. We also have been selling ZFS-based products primarily for people who are looking to do NFS and other file system protocols, but we also offer a virtual AOE product as well. So you can have a ZFS-backed AOE share like if you're familiar with Comstar or in the Linux world, iStudy shares from the Z-Vault, same sorts of ideas. And we've, of course, been shipping for a while to Investor. A couple of things I can talk about today, what we are currently shipping and currently have available that I've been working on specifically is we're moving to using Collect B. And a lot of infrastructure people use Collect B or something similar to it for centralizing telemetry information. Collect B is an open source project, and I've got a bunch of new agents for ZFS that are ready and allows us to get a lot of the information out and then upstream so that you can deal with the data. I have a picture to show you how some of that works. The easiest way for us to, in the Solaris environments, Solaris derivative environments, is to use K-sets. So we use those quite a bit. I've also got some stuff that I want to come out with. Is if you use Arc Summary at all, I know it's been around for a long time. Yeah, Arc Summary is great. It hasn't been touched in about 8 years. Right? It doesn't even do O2. So I've got a Python-based replacement that is more up-to-date, more comprehensive, that we call K-Stat Analyzer. And it has much more information. It'll tell you how well your prefetch is doing and all that sorts of stuff as well. We'll get that out very soon as well. One of the things we can do when we get all the K-Stats up and we can graph those and collect them and show them to you, then you can start to do some pretty pictures like this. And one of the things that we're trying to get people to start to look at from, for example, in the ARC perspective, the hit-to-miss ratio represented as a percentage is not really terribly useful because it doesn't show you the magnitude of that percentage. And so by graphing things like on the ARC hit-to-miss ratios, green is good, red is bad, so green are hits, red are not, of the various kind. And a quick glance at that kind TV, this is Giraffe. But the key thing is getting the data out and making sense of it. Well, why are we doing storage ZFS at core rate? We've been doing AOE direct, or obviously directed this for some time now. But the fundamental thing and why a lot of us use ZFS is storage hardware breaks. All of it breaks. Firmware has bugs, lots of bugs. And the breakage arises in strange and mysterious ways. So this is an anonymized version of a portion of a Z-equals status output. And you guys have seen this probably. Anybody in production know it? Those are cool. You've seen these kind of things. So we have all these checksum errors and all these things with history sobering. I actually have breakage in here. The slide that's inserted will come up later. Actually goes into more detail about breakage because the driver comes back and says, well, there's no unrecoverable read errors. And ZFS says, look at all these read errors. This is crazy. And so obviously that corruption propagates up. But here's really what at the end of the day matters. Right? This is why we do this. Right? This pull is corrupted, it's very large. All the hardware is broken on it. No data errors. This is why we use ZFS. Thanks. Is work that needs to be done, but it's not heavy lifting. It's more the interesting things about how we put it together for the analysis. And then also, as you know, there's a Python version of WorkStat as well.
I have a quick question. I'm going to have to log all my companies together, and we're using the same infrastructure that you're using, and we actually open source our case data analyzers and the collecting feeds. So I was wondering if you did the same with yours, or are they
will. I just didn't do it on the plane last night, so very, very soon. Because a lot of these things really, for the community to understand how systems work and to share debugging experiences for these things in the field is very important. In addition to all the development work that goes on out there. We have to make these things work in the field.
I was going to say, we open sourced our Python rewrite or summary 2 years ago.
Yeah, exactly.
Have we all done this now?
Yeah, there's a whole bunch of that. Yeah. Now, to be fair, we shipped Solaris 11 as well, so not only does it work on the new OpenZFS stuff, it works on the old Solaris 11 stuff as well.
hardware manufacturer, ZFS specific, well maybe not specific, but ZFS specific hardware. Thanks.
Christopher George, founder of DDR Drive, and the architect of our main site, DDR Drive S1. And just proud sponsors of OpenZFS, and this will be a super short presentation. So that's our product on the screen, and basically we match the speed, performance, reliability of DRAM with the non-volatility of NAND using a PCI Express 4 This is with a depth of 32 cube. So, yeah, you definitely get a benefit. A cube of depth of 1, the latency wouldn't be as great as 25. I would say it's more like 15 or 20,000 IOPS. There's a definitive benefit to having a higher cube.
How do we see this? Is it an HDI device? How do we see it in our system?
You see it exactly like a hard drive. So we type format, that's your question.
Special block drive? Is it a special block?
No, it would look exactly like a SCSI device, like any other hard drive. The idea is that hopefully it would be exactly the same as far as it goes.
So that change for that kind of special block device, it's now just a, it looks like it exports SAS.
No, we originated with basically SCSI compatibility. So we actually look just like a SCSI HBA that happens to have a 4 gigabyte SAS drive attached. But we have talked about actually having a block drive that enables us to remove the SCSI overhead. And that could be something we're really interested in. One of the only reasons we haven't done that is you lose some of the normal usage, like typing with format here and things like that. As we're looking at porting our driver, which is currently only Solaris, to Linux FreeBSD and VMware, we're hoping to actually take advantage of more simple libraries and things that are going efficiencies.
How big is it?
4 gigabytes today,
4 gigabyte?
correct? Which happens to match the default of the right volume. Again, for the future, we're looking at 8 and 16.
Yeah, so how does it compare with Sysra?
Zeusram's a great product. There's a few differences. So Zeusram is a SAS-based, so it's going to attach to an HBA or PCI Express based. So there's some latency differences. We like to think about the benefits of PCI Express. We talk about a single hop. So there's one hop from the controller, basically from the CPU to the controller that's on target.
A better question probably be how do you compare against the likes of the S-Tech S1120 series, which uses not RAM, but SSD. I suspect you have a better latency, but have you done the challenge with it by any chance?
I haven't actually installed a benchmark that device. It's flash-based there.
Yes, that's why I was thinking we still have latency.
How many lanes are in the direction of PCI?
The current product is actually Gen 1 by 1. The next generation will be Gen 3 by 8. And then just to follow up, try to finish the earlier question about the number of hops differences between Zeusram. But like big picture, the biggest difference is Zeusram by nature being SAS and dual ported. So that would cover an HA environment, which we currently do not. So that's a nice benefit of Zeusram. And what I was talking about, what I think is really, to me, the ZIL is really all about latency. And the first gentleman asked the question, I'm really nervous, so I apologize. I'm not going to speak on it. But, so the number of hops really ultimately determines this latency value. And so what you need, again, I was saying, is one hop from the CPU to our single controller that's on guard. And then the Zeusram, really the best case, is a single hop from the CPU to the HBA, and then from the HBA to the Zeusram itself. And then in many cases, that Zeusram is actually out in the JBOD. So now you have 3 hops, CPU, HBA, and the standard. And it's also bound by the latency limitations of SAS, which is a connection-based protocol. And then a lot of times that drive is also with intention to traffic. So what's really nice about PCI Express is you inherently have a dedicated path for the ZIL traffic that would in no way intend to be traffic. But again, it's definitely serves a great purpose in that form factor. It's a much different money that we offer. And it's, depending on what you're working on, that's benefits. They have slightly higher throughput because of SAS. But the latency, I think, we have benefits as well.
Last question. So I'm curious, some of the things that I was with Intel drive or any other super fast-based drive, where it actually increases security or it's like having the green state and then just having
complexity of the LBA table. So within those random rights, as the LBA table gets more and more fragmented, and then that's going to fundamentally affect performance. I think that's what you're seeing, which would also be mitigated by trying to minimize that flash flow.
So now I will try to time myself. George, if I start going over them. I'm Matt Ahrens, I'm a principal engineer at Delphix. What does Delphix do and how do we use ZFS? So the problem that we're solving a bunch of problems, but the kind of most basic and easy to understand one is that our customers are running production databases on a big expensive server over there on the left. They're running Oracle or maybe SQL Server or maybe Postgres. And that production server is it's very special. Right? It's on very expensive hardware and it needs to be managed very carefully. People aren't doing development on the production database server. They're not doing testing on the production server. So they're creating a copy of that data from the production server and putting it onto another server to then do their development or testing. So when I'm talking about development and testing here, it's development of new application level features. So for example, like adding new stored procedures into the Oracle database, adding new tables or new rows and columns to know about new things that need to account for given new accounting rules or a new product that they're launching. They need to keep a new warehouse. They need to know about new locations in there. So making this copy of the data from production to their non-production copies, the most obvious problem with that is that it takes more storage. So every time you create a copy of the production data for your development use, that's a whole other copy of the data. It increases your storage costs. The second kind of perhaps less obvious to an outsider problem with that is that it takes a lot of time. And it's not just the time of performing the computer performing the copy. It's also the time of getting the storage, getting the production database admin to agree to create a copy of it, because there's an impact to the production database when they're performing the copy. So Delphix allows you to create copies, quote-unquote copies, of your database in the form of virtual databases for non-production use instantly. So how do we do that? This diagram shows kind of how the pieces are put together. So on the left is the production database. That stays all the same, so no impact to the production server. We have our Delphix engine in the middle here. This is a virtual appliance. So in other words, it's we ship an operating system that runs on top of VMware and then attaches to whatever storage you have already, typically over Fibre Channel. So we pull a copy of the data from the production server using Oracle RMAN or kind of equivalent technologies for other databases. We pull in that copy of the data using the normal Oracle RMAN backup solution into our Delphix engine. We store it using ZFS on that storage there. And then when we need a copy of the database, a new VDB, then we create a new ZFS clone, export that over NFS, and then run the Oracle database on these other servers with the storage over NFS to the Delphix engine. And so from the ZFS point of view, it's like we're just creating a bunch of snapshots and clones. The whole rest of the product is how we interact with all these other systems. So automatically being able to set the right settings. So if you, for example, if your production database uses a terabyte of RAM, but your non-production databases you don't want to use a terabyte of RAM, you can set up all that in the Delphix engine, and it'll automatically set those settings in the Oracle database. Also, you can do provisioning to not just individual snapshots. So you take ZFS snapshots every hour or whatever. But with the Delphix engine, you can actually provision your database to an exact point in time. So up to the exact transaction. We do that by orchestrating and telling Oracle how to play the log files forward to the exact point in time that you want it to provision from. Any questions about that kind of basic usage model? So there's a couple of other things that One is running on top of Amazon EC2. So this is, rather than running on top of VMware, running on top of Zen. One of the cool use cases for this is, like let's say that you have your production database on-premise. You can use two Delphix engines. One Delphix engine that's on-premise, taking the copy of the data from Oracle, and then use Delphix replication, which is based on ZFS 7 received, to send that data to another Delphix engine that's in the cloud, running on Amazon EC2, and then provision there for doing your testing or development. We also run with Microsoft SQL Server and other databases. There's a couple of minor differences with SQL Server. So SQL Server doesn't have the same kind of sophisticated backup techniques that Oracle database does. So we need this intermediary server. So basically what's happening is the production database server is sending its log entries to this secondary server, which is playing the log entries into another copy of the database, and that database is stored over iSCSI to the Delphix engine. So what's unique or interesting about how Delphix uses OpenZFS? I think kind of the most interesting thing is that we depend on lots of fast clones. So all the virtual databases that we're provisioning, that's what our customers are using for all their development testing. So they could have hundreds of employees that are using these VDBs. Those need to be really as fast as possible. And the OpenZFS, the way that we implemented snapshots and clones means that clones reference the same data that file systems reference. They reference it the same way. So there's no additional layers of indirection because it's a clone. So even if you have a clone of a clone of a clone, accessing that data is just as fast as accessing a regular file system. Another interesting thing, we run on reliable enterprise storage rather than on plain disks. So we aren't using RAID 0 mirroring or anything. So we're relying on that, but then we're at least using ZFS checksums to verify that that reliable storage is actually reliable. Last one I'll mention is so we use SHA-256 checksum algorithm, but not for dedupe. We use it for this new feature that Georgia implemented a couple of years ago called no-operate, where if you write the same data on top of a given block, so you have a block of a database, say, that's already been written, and then we write what happens to be the exact same data, then we look at the checksums and can determine that, oh, that write isn't, we don't actually have to do that because it's just the same data. The advantage of this is, yeah, we don't have to do that additional write, but the bigger advantage is that we don't have to break the block sharing and consume a whole other copy of your database. There's some use cases where we have to resync the database, which requires basically rewriting it all, pulling over another copy from the production, because essentially the production database forgot about how to do incrementals. So this really helps us there. So last couple slides, how is Delphix involved in the OpenZFS community? So we're the top code contributor to ZFS. We've implemented a ton of features that are listed here. But beyond that, we do speaking at conferences. We've spoken at 8 conferences this year. And obviously organizing this developer summit, pushing our code changes to the most. So we see this as really a big benefit to being able to continually pull down changes that other people are making. As I mentioned, we make a lot of changes, contribute a lot of changes to OpenZFS on Lumos. We have about 5 developers who are working at least half time on ZFS. I think most of them are here today, so we say hi to them. And over the past about 3 years, we've had 10 employees contribute to Lumos and over 140 commits and 28,000 lines of code. So, cool. That's all I have. I have 1 minute for questions.
Yes. So you mentioned something about making clones of clones of cost. Like, how far the same program is like a secret source that you guys use yourself or something?
I think you guys see is there some proprietary ZFS stuff?
Yeah.
So all of our work on ZFS is open source. That clone of a clone of a clone thing, that's part of, base ZFS going back to the original design. Yeah, that's happening in the process.
How much work was involved in the up to
Do you do that?
Yeah, I know that. It took a couple months. There were some problems with, it wouldn't move for a while, and then the drivers wanted some features that CFS relies on. But those changes probably went streams.
Would you guys like a faster hash, or is it not?
It would help us to have a faster hash. For the time being, it's like we can just tell the customer to remove more CPUs because then it scales perfectly. But if we had a faster hash, then that would be useful.
Yeah, when is SHA 256, SHA 512/256 oriented?
As soon as somebody sends me what's the code for review. So.
Or there was discussion.
I don't want to go over my 10 minutes, so thanks guys, and come talk to any of these Delta guys afterwards if you have more questions. So next up is Alex.
I'm Josh Petzel, I'm here with IX Systems. We call ourselves the oldest startup in the valley. We're an outgrowth of BSDI. We have some original Telenet employees from circa 1992 still working for us. BSDI decided they wanted to be the next Sun, started getting into hardware. It was a software company made this thing called BSDOS. Kirk, you remember that, right? They decided they wanted to be like Sun. They made a hardware arm they called it Unix Systems. They promptly got sued out of existence. They renamed it IX System. A couple months later, .com crash, and a bunch of employees bought IX Systems for about $50. That was about 2002. And so they were making hardware. They always wanted to get into making software. And about 2010, we acquired this project called FreeNAS. FreeNAS was built on FreeBSD. It was a storage appliance, like web-based thing you could install. They were going to convert to Linux. We just got ZFS support. At that point, Linux did have ZFS support. The community had a big outcry, and so the founder of the project gave it to us. And we said, hey, we've been wanting to get back into software for a long time anyways, because making servers is quite frankly boring, and there's not a lot of money in it. And so we started doing FreeNAS. We rewrote FreeNAS. Along the way, we ditched 32-bit support. We ditched, unfortunately, we ditched UFS support, right? It's a ZFS appliance now. And so we thought we'd rewrite that in about 6 months. It's been about 4 years. We're still working on writing it. In fact, we've now reached the point where our rewrite needs a rewrite, and so we've started on that. We track OpenZFS pretty closely. We have a bunch of FreeBSD committers on staff, and so FreeBSD is very important to us as well. But we think we stay as close to or more than in sync with OpenZFS than anyone else that uses ZFS. So pretty much Shin, who just left, pretty much OpenZFS or LumaOS does a commit, and Shin does it the next day in FreeNAS. So we also decided that software-defined storage like FreeNAS is really, really hard to sell since we're a hardware manufacturer and they like to sell things. We had to sell FreeNAS as well. And then we ran into some people that had a lot of trouble buying something that was called free. So but there's a thing called TrueNAS that's mostly like a crippled version of FreeNAS that runs on a specific hardware platform. So much like the Unix command less means more, TrueNAS is less and more than FreeNAS at the same time. So that's all I've got.
Hi everyone, I'm going in and I'll do a brief introduction on Extended Systems. So Extended System is based in Santa Clara, California. Around 2005 or so, our founders, Alex Eisman and Dimitri Yusupov, saw an opportunity to create an open storage, an open ZFS storage appliance based on ZFS, Open Solaris, Illumos, and that. I'm sorry. Open Solaris, Illumos, and Open Solaris at that time, and basically to create the storage appliance. We started that in around 2005, 2006, and had the first shipping product in 2008. We have quite a few customers in all different industries. We have a pretty well distributed engineering team in the US, in the UK, EMEA, all across the US and EMEA. So I'll be talking about the two basically major products that we have in the store. In the store, as I said, is Illumos-based SDF solution based on commodity hardware. The idea is we provide a software stack that allows customers to go out and basically buy hardware from a hardware vendor like Dell, Supermicro, Quanta, IBM, HP, and basically build their own storage appliance. They can start with something small, scale up and scale out as necessary. The idea, the true value is that we provide a low cost, open source, high performance NAS and SAN solution. And of course, you guys are all familiar with all of the benefits that we have that we get with ZFS. We also support hybrid, and we will be announcing support for all SSD appliances soon. The other product that we ship, and just at a high level kind of understanding of this, is Extended Connect. It is basically a virtual SAN integrated into vSphere, a virtual SAN for VMware ESX. It is a NAS appliance that is optimized for VDI type of solution, providing storage to VMs. The really neat thing there was the Extended Connect team did a very good job of integration with the vSphere management interface. That is to say, we can go to vSphere, go into the vSAN management, configure and provision VMs using one single interface. Community involvement, we are mostly a ZFS and Illumos community member. We are, in a sense, interested in the core features of Illumos because we basically take advantage of everything in Illumos, from ZFS to NFS to SMB. We also work on the Comstar block storage provider, high-speed fiber channel, drivers, MPT SAS, FMA types. So, in a nutshell, that's who we are. That's my setup. Happy to take questions. Yes.
I heard that you guys were working on some SMB3 stuff. What does it say that, and what is the benefit? Like, I don't really know that much about SMB, so what's the benefit of that for
So I believe SMB 3.0 is more server type of protocol. But SMB 2.0 is still I think SMB 3 is more optimized for server production.
You get server-side copies. That's the big one.
Matt, there was also a talk about this at the Windows Day.
Yes. Yeah, storage. Yeah.
Yes, in terms of the state of that, voting and getting more to on that, I don't know what the ETA is. Thanks, guys.
Good afternoon, my name is John Nagel. I'm historian in Boston. Some of you might have known me for Sage Five, or this year. Take a few minutes to tell you about our product today. So we brings a table with private cloud storage and public cloud. What that means is that we're able to provide all the benefits of private cloud storage to public cloud providers. You probably are all aware that public cloud storage is only a year, right, per month. There's private cloud storage, only 30 to 50 cents. So, for various reasons, there's a lot of companies out there that want public cloud storage, private cloud storage, security comes to mind. So those are the type of companies that would be interested in our products. This is a simple graph showing that the annual IT budget for most companies is about 5% growth. Storage cost is 60%. When those economics work, companies need to find cheaper alternatives to data storage. Some of the benefits of our product, reliability, and power. Backup and archive, we're SEC compliant. Isaac and streaming speeds, almost PCO, 2.7 per month. And one of the unique things we bring to the table, we have data storage, we have power government to spin it. We will actually spin it down, as you can design use. Therefore, instead of like design, you double, say, power consumption. And we also use commodity hardware. State drives, not SAS drives. So that's the and we'll configure to the size and performance to scale out the hash storage. Typical rack drives, 1.2 petabytes. That's not enough for you. And we have high throughput support data analytics. You may notice the title of the slide was all your big data. That wasn't intended on. Because we see ourselves in the future, years before people actually using big data products on the computer, data that they have stored. So rather than just having the data sit around the archive, it's useful to actually where data on the data, because we store the data in some data logs and data. This just shows a slide of where we position ourselves in storage tier. We don't claim the tier 0 or 1 arena, but we do find ourselves between 2 and 3 high volume storage and archive storage. Yeah, these are some of the interfaces we support for getting your data into our product. We support some of the old trusted protocols such as NFS. We're also on the new Amazon and Swift. And we have also provided various client libraries we see. John, I don't know about that. Buy a product and just be regular existing applications. We want to Just an example, topology of how product. In this example, we have two sites. This would be an East Coast and West Coast solution. And ZFS, OpenZFS here on storage server there in the middle, which is connected to a JBOD. And I think I mentioned we can have 4 or 6 JBODs interact. Stored. And then the customer data up in the upper left, using one of our APIs, how you can get it into the system via the data network. It's all stored on OpenZFS. And we use the Cassandra on the management side for managing the metadata. We give you access to the operating console. And here's how we use OpenZFS. We're actually running OpenZFS on Ubuntu. And it runs independently on each storage server. That's what we passed last time. And our software manager sets its equal as a unit by which our standard. You can actually have dozens, if not hundreds. Each storage server has up to 4 data log tabs. The software orchestrates data management across these equals, managing copies, power control, and automatically initiating to replace the master files, which is another feature we have. That's something that doesn't currently have and we utilize the data integrity features of OpenZFS, speed scrub, we have anything done, scrubs, periodically, another fraction that putting the data in full storage, having sit around 5 years, when we do need it, making that call up, retrieve the data, and get it back. Periodic maintenance jobs, scrub jobs, and I already mentioned those spin up equals and shut down. A little bit about how we contribute to the community. We're advocates for OpenZFS on Linux, pushing the envelope in some areas, currency is not. Contributing to a few bug fixes thus far, and the regulatory handbook is confident that we're chasing 2 potential issues. Too early to know. And we to do some of the things we did, such as importing and exporting volumes, scrub jobs, programmatically, and working on the API. And most important of all, is launch today's VFX. Any questions? Yes, we did. We took a look at it in 6.3. Didn't have everything we need yet, so we had that for a while. No, it isn't open issue because it's known that it's not complete. Was that? No, I don't have that information with me, but yeah.
So you mentioned spinning down disks on the Z pool. Is that just when the Z pool is completely inactive, or do you support limited rewrite functionality?
It has to be completely inactive. If there's any activity on the disk, see if that's anything that's spit out.
Well, yeah, I'm thinking of like cases where like you open a file that's entirely hard, where like, you know, the DBA kind of like happens where you sort of Brazil,
No, we will have to spin up the rest of our software. We have a file, determine what is equal on, and spin it up. It's tough to say, but probably depending on the size of the vehicle, I'm almost selling out 26 discs. I think we're going to have one storage server, that's what they were, where to sold one petabyte system now. See what they're doing.
So when you get into the other, your team, terabyte size,
When you have a partition in the pool?
yeah.
Well, for instance, one of the enclosures that I'm working on now has 6 sub-enclosures. Each sub-enclosure has 16 discs. And if you pull out the sub-enclosure, it has to go to the loader and do it like this. So in order not to break rate, you're not going to want more than 2 discs. Take this up. So it really depends on the sub-enclosure. You have a template, this sub-enclosure like A. So very like this. No, not size. How many? Well, you have 4 of these big ones in a rack, and you have as many racks as you want. Oh, each closer.
Hi everybody, my name is Dan. I work with a company in Europe, and we started out as a company who is building appliances. And our first products have been network appliances. They were unified threat management solutions. We started out by building those solutions in 2000, and those were built on Linux. The thing is that we accumulated a lot of experience of building one product which delivers a certain experience to the customer, like, I don't know, building washing machines. And over the years, we found out that the networking appliances market is going to commodities, so we tried to find out a different venture. And this turns out to be the storage market. And we started to evaluate whatever was available in the market at the time, and we found out that the best solution for a storage appliance was Illumos. At the time it was called OpenZFS, and it had a very bright outlook, and it was looking very similar to Linux, was poised to have a great community, and we bought into that new operating system, and today we're glad we did, because what we ended up finding was that ZFS is such a great platform. And I can say that for all the storage appliances that we build, we've never lost data. And this is amazing. I mean, even though we had downtime, we had to recover tools, some of the previous speakers were saying that they never had data loss. And this is the same thing that we experienced. And this is amazing because we were used to having all kinds of problems. And yeah, we started out, we continued, we went a little bit further, and we tried to propose ourselves as a software solution. And we thought that that was a great idea. And the problem is that we found out soon that you cannot just do software without thinking about hardware. I think that the best way to deliver a consistent, good experience for the customer is to integrate software and hardware. And this is what we set out to do. And this is our mission right now, to bring the simplicity and the peace of mind to the customer. And that's the only way to go forward. And we base our work on ZFS and Lumos and the hardware engineering that we have experience on, and we try to bring them together. And on top of that, we provide the solutions that we have developed. We have built great VMware integration. We work together with the VMware APIs to keep snapshots in sync and to provide synchronized and complete virtual machine snapshots, so that we can, for example, for VMware, we can allow the customer to have an unlimited number of snapshots in time without having the problem of having the snapshots growing and growing and growing over time and having them consolidated easily. Then we use the send and receive to implement replication solutions from one storage to another, and we accelerate the storage access by using the ZIL and the R-cache, and some other things that we improved were, for example, we also provide high availability solutions, which are based on a port of the Linux HA clustering to Lumos, and yeah, this is what we do. And I think that we'll be able to bring our products to the United States, but right now we are just in Europe, because we need to be able to control what we do very well, and to build a great experience, and then to be able to replicate that to other countries. And right now we have installations in all over Europe. We have installations we started out from Italy, and then we went on and started to evolve into the rest of Europe, in Belgium, in the UK, in the Netherlands, and we're slowly growing, and that's it. Okay, so for VMware, we communicate by sharing over iSCSI, Fiber Channel, and NFS. But we also communicate with VMware through their APIs. The integration that we created, we also released as an open source project. You can also find on our GitHub account the various things that we did. Our HE solution assumes that the storage is shared between multiple nodes. So that kind of sharing can be done through SAS, for example, or through Fiber Channel. Yeah, well, that's the. Of course, there. I wouldn't call them tricks. I mean, this is HA. You cannot import one because ZFS is not a clustering file system. You cannot have the same tool imported on multiple nodes. What we do is For example, we can create multiple pools and have them one pool on one node and the other pool on the other node. And we can migrate the pool from one node to the other, and we actually protect against multiple pool imports by using SCSI reservations. And that works either through SAS and or through Fibre Channel.
You guys have like,
Yeah, we've been doing some work on that because that's one of the most important things. Import must be as fast as possible, so we delegate or we background all the things that are not essential to have the pool considered as being imported. And the same goes for the export. But if a pool, for example, on export times, if the time limit is not reached, for example, there are some, it's actually locked, and it cannot export the pool, then the pool will stop. The node will stop itself if it doesn't reach the export state in a certain point of time. So it will just get killed and moved over to another node.
Investigated speed of power as a zero decline on the port. We need to have fast support time. That's one of the two major, or actually I think three laws having equally fast. One is zero decline, another is async destroy, and the other one is just data sets that will keep them resolved.
Okay, so there are multiple things that can be done. ZIL import parallelizing we didn't investigate because it hasn't been a big problem for us on import. But for example, mounting multiple file systems in parallel, that was something that we did to speed up the import process.
Are the changes open source that you send back to your
They've been, okay, so if you're talking about the whole HA system,
No, I mean the powerization of data.
yeah, we've got our, we didn't try to integrate them, but we actually, our repos are online. So I mean, they're on GitHub.
Hello, good afternoon. My name is Nelson. I'm here representing the Clean Labs. We're sponsoring the engineers here in the area, working on wireless and wireless surveys for processes. So we started with this motivation. We looked at the computation of these tasks, such as cryptographic caches, and data compression and encryption of these tasks are typical for processes. Also networking, and we looked at existing hardware accelerated solutions, and noticed that many of them have power head and redundancy, and to actually get to bandwidth that those plans under those solutions allow, we need to really exploit a lot of power concurrency, because we have a lot of flows in the processing hardware to get the full capacity of the device. So it's not very useful for businesses application or highly concurrent applications. And one example that we specifically spent most time on is ZFS SHA-256 application. This is cryptographic construction, and it's used for data clarity in ZFS, and also used for deduplication in ZFS. And this is our example of the 6-core single reach processor. You can get almost 0.6, 0.7 gigabytes per second performance if you enable SHA-256. Most many times it just gets disabled because it uses too much CPU. So this is our solution. So all this here is in the picture is the actual card that we have currently. This is our newest card. It's based on Altera FPGA Strength 5. So this So for this specific application, like Child 56 application, we developed a very low variable way to do latency interface that minimizes the number of PCI round trips, relaxed DMA, and Child statistic computation. It doesn't do any additional buffer management, any additional context, any allocations, zero problem. It doesn't store DNA descriptions in memory. And the interface is optimized for multiple CPU applications. It's almost free, so we are minimizing releases to almost non-existent. And because there are always actually to minimize the latency and minimize the runtime here. And we integrated it with ZFS. We used open source ZFS. We tried it in both Linux and Windows. We have drivers for both Windows and Linux, driver for our FPGA. And what the driver does essentially, ZFS we have a vector of functions that ZFS uses. And we just replace the SHA function with our own function in the kernel. So no source code changes for ZFS is actually required. I mean, initially we actually started with some modification, but it turned out that we can really without any modifications to ZFS, we just load the driver. That's it. And here the comparison that we actually are playing with our user card, it was based on the array 5 FPGA. So you can see a comparison of CPU versus CPU plus the FPGA. We get about almost 3 times speed up. And on the newer card, we're expecting almost 6 times speed up. This is a latency comparison between the cards and your CPU solution. And since we were asked by several customers who were interested in this specific block sizes, 4 kilobytes and 64 kilobytes, that was the most latency impact. And so we have this numbers for our latencies, and you can see that our newest card is almost twice faster than the same CPU and even the older card is still faster. And these are the graphs we obtained also in the other card, both older and newer card. This is how the latency changes with the number of concurrent requests and how throughput changes with the number of concurrent requests. And so we can see the latency is pretty stable until you actually saturate the FPGA. So our FPGA has 16 regions running. So you see that for 16 regions, the latency starts falling. And throughput stabilizes. That's maximum. It shows that our throughput on the unit card. Once you complete eliminate the limitation for the next FPGA throughput. And we're looking at further extensions of the technology, potential applications of the compression, sliding window caches. These are random fingerprints. I know how useful it is kind of means because they're not used. But in general, they are used for more advanced duplication. It can be used for encryption, and it can be used for any combination of the above, with the advantage being that it can be done in parallel. So you can do compression and checksuming at the same time. And here are conclusions. We have high throughput hardware accelerator, with low overhead, low latency. It has very similar integration with ZFS. It doesn't require any changes to ZFS. Demonstrated 3 times throughput improvement, and actually it will be over that. And if anyone is interested, write us an email at info. Any questions? Yes.
I'm curious, who benchmark this on Linux or Windows?
So we have a benchmark. So the numbers, we have similar benchmarks for both. The benchmark that I included in the slide was on Linux. But we have like very similar results for Linux.
Did you do any benchmarks on how the card would improve DDoS performance? 3 times was for normal checksumming, or would that bring DDoS performance?
It's not very clear how it would be. I mean, we just measured how the checksum computation is improved. It can be used for anything. We didn't run any benchmarks like specifically to measure. But the thing is, it's not clear what exactly we measure. essentially, you still get the same result. If you have to compute that many checksums, this is what you get. So I'm not sure that every decision we do will change it in this case.
Yeah, because if you overhead checks.
Yeah, if you overhead, then you will not need, you'll need to read, to write, but read you still do if you don't have this, don't have that information. So for read, it will not.
My question was like, does it bring an improvement to the data as opposed to using CPU for data? That was
Well,
question if you did some.
So we didn't do any, as I said, like, we didn't do any specific benchmarks, but we expect the same improvement, like, because if we compute the checksum to actually do, if you do the checksum, if you look up, then if you look up as a heat, it's a heat. So if you suppose you get like an ideal, everything is matched, then you will get 3 times improvement. If it's not ideal, then you will get like, less than, if you have to write extra blocks, then it depends on how fast your disk is. But it's not really tested our technology. Yes.
Can you share what kind of encryption performance numbers you're getting?
No, yet. We don't have numbers for encryption. But yeah, our bottleneck is PCI. Not users, but the speed of the data going to the PCI.
You said so for CPU, doing caching, they do like 0.6
Yeah.
gigs per second on CPU, and you said it's about 3x improvement in throughput, so that's about like 1.8, 1.9 gigabytes per second.
Yeah.
So, sorry,
With your PCI file.
Right now, yes. But
with modern ASI encryption, offloading to a processor is not as useful as it used to be, because a modern one-core processor can do that in 5 seconds.
Would be good one. You found your own. That's the deal.
Well, yeah, no, I know, but XCS is, when you take into account other stuff, yes, you can get, I've done 2 gigabytes per second XCS per core, and when you have to take into account everything.
Yeah, yeah, no, it's not 3 gigabytes in PCM.
So the last talk, come up here, just a couple of announcements while I'm up on here. The location for the hackathon tomorrow is not here, so don't come here. Come to the Delphix office in San Francisco, which is about 2 blocks from here. You can see it on the map. It's the same time. Come at 9 o'clock for breakfast. Hackathon starts at 9:30. And after this last talk, then the beer batch will be here tonight until 8 o'clock. So everybody keep in mind you need to leave by 8 o'clock. So if you want to drink 7 different amazing beers, then you will want to get started very quickly after this last talk. And the question is, Anastasia, how are they getting to the office? Ring the buzzer, or is there? Okay, so someone will be downstairs to let you in to the office. Yeah, don't show up before 9 o'clock, please. Great. Good. So next, Luke from Free Street.
So I'm conscious that I'm standing between you and your peers, so I'm just possible. Brilliant. So I'm going to talk quickly about what we're doing at Cluster HQ, but instead of talking about what we're doing, I'm going to show you. So
just very quickly, who here has heard of Docker? Yeah? Okay, so what we're working on at Cluster HQ is a way of making applications that developers are building with Docker run really well across multiple hosts. And one key thing to keep in mind about applications that developers are building with Docker is that they're building them with a certain set of abstractions. The abstractions are ports, links, and volumes. Ports are how you access an application from the outside world, it's basically a TCP socket. Links are basically TCP connections between containers, and volumes are things that you allocate to a container that a container can use to store some persistent data. And with Docker today, you can run at a time, sort of one container on one host. There's a piece of software called Fig, which allows you to connect containers up into a set of connected containers and run many containers on one host. But with Docker, you can run many containers across many hosts. And so I'll show you that. So the demo application I've got for you today is pretty much the simplest web application you could possibly imagine. So you can see this. The application is just a Flask application, it's a Python program, and it implements an integer and tells you how many times the integer has been implemented. It's pretty revolutionary. So first up, I'm going to show you how you can run that application with Docker. And so the nice thing about Docker is that it allows you to describe that runtime environment and execute that application in a consistent way. So the exact same bits get run wherever you run it, assuming it's on Linux. So we can just type Docker run, and it will start up our application. You can also build that app and push it to the hub and then fetch it somewhere else that will be consistently run. And so, okay, that's running the Flask application, but there's no Redis server hooked up to it at the moment, so it's doing no message. And so that's all great. The next part of the demo is how you can hook that container up to a Redis server, which is what that container is expecting. So the point of Fig, as I said, is that you can describe an application manifest, which is just a YAML file, that connects containers together with links and defines volumes for persistent data and ports for how you actually connect to that thing. So I'll show you the Fig file quickly. It's just a YAML file. Let's see. Can you read that? So there's a web container that refers to an image, a link from that web container to a Redis image, a port that's being exposed, and a volume for the precious integer. So let's see if we can run that. We just type Fig up, and it uses the YAML file in the current directory. And there we go. So now we can see that this page is being reloaded 15 times. It's amazing. Okay, so that's great. But what if your integer incrementing service gets really, really popular and you can't run it on just one machine anymore? So the next thing I'm going to demonstrate is Flocker. And basically you can think of Flocker, which is the open source project that we're building at Cluster HQ, as a multi-host version of Fig with support for portable volumes, and that's where OpenZFS comes in. So in addition to the application manifest, you can find the deployment manifest, and the deployment manifest looks a little bit like this. If you can see the red text. So basically, you define some servers, you can have multiple servers, and you say where you want the containers to run. Those are just the containers you referenced in the Fig file. And so we've got two different versions of the deployment manifest here. We've got one where both the containers are running on one machine and one where they're running on the other machine. So what I'm going to do now is show you. I'm going to show you. So here we've got those two machines, and you can see that at the moment. So this is a Flocker cluster I've got set up. So here you've got two machines. Currently, both containers are running on the first machine, and if we look over here, then we've got the same application running there. And so going back here, we can now run Flocker deploy,
And Flocker deploy takes the same fig file as an argument, but it also takes the deployment file. And so if we use the deployment file in node 2, then what that's going to do is, that's running at the moment. So what that's doing is it's taking a new ZFS snapshot of the data volume that's attached to the Redis server. It's a more than it's actually Redis. Takes a new snapshot while the container's running, does a ZFS send to the machine, then shuts down the container, takes another snapshot, does another ZFS send, starts the container on the other side, and reroutes the network proxy at the top. So what that means is that without the client of that Redis server noticing, it's being seamlessly moved around. So it's a bit like vMotion for containers. So that's finished. And if we go over here, you can see that there's now a Redis server running on the other machine that's been live migrated over there. And if we hit reload, then the application is still running. That's the demo. And that's it. Cheers. Check this out you can try it yourself. Please download it and play with it. It's a vagrant thing, so it's really easy to try it on your laptop. Come and hang out with us on Freenode, and we're also hiring in San Francisco and Berkeley. So, cool. Any questions? Yeah, you make Docker understand ZFS, or do you do that outside?
Did we make Docker understand ZFS, or did we do? At the moment we're not using ZFS for the Docker images themselves. We're actually just using them for the volumes, because you can bind out an arbitrary path outside the host into a container. But it would be awesome to have a ZFS en route where you're using the ZFS driver for the Docker images as well as for the portable volumes. Sorry?
We enjoy having that.
Cool. Any other questions? Great, it's time for beer.
A couple of things at the end. First, thank you to all of our speakers today. Thanks so much for coming out, guys, and giving me a great Anastasia here. All right, Anastasia, wherever you are, thank you so much for your hard work organizing all this, and it couldn't have happened without you. So enjoy the beer, and we're going to go 8 o'clock.